All right, guys. My name is Ivan. I work at a company called PSPDFKit. We basically do PDF framework. So what I'm going to talk about today is Android animations powered by Kotlin and RxJava. Now, before we start, I would like to ask you, like, how many of you actually done RxJava? At least any basic level, whatever. Okay. Okay. There are some things I couldn't get around with. Like, if you don't know RxJava, maybe some things won't be clear. I try to keep it simple, but if you want to implement what I'm going to talk about, eventually you just need to go through some basic RxJava first and then do it. Okay, so animations on Android. There are like 4 classes that are kind of used by default on Android framework. First one is value animator. Value animator, as you may already know, is the class for animating values, as it says. So you have out-of-the-box methods for animating specific values, mostly primitive values. Then you have object animator, then you can apply on objects. We'll go through each of the APIs. Then you have Animator Set, which you basically use for scheduling animations. You want to do this one first, then this one, and execute them in some kind of a sequence or whatever. And then finally, we have View Property Animator, which is what we're going to use mostly. So we're going to use this View Property Animator API and then wrap it in RxJava in reactive base. So let's look at Value Animator. So basically, Value Animator, as I said, animates a value. So you will say value animator of float. So you want to animate float from 0 to 100. You set some duration, and then you start the animation. So how it works with views? How can we animate views? So we will basically do this, and then listen for values of that animator. So as the value gets updated, we will apply that value to the view, which is not a really nice way to do it. So for example, in this case, we want to move the object from 0 to 100. We want to change the translation value. So we're just going to say, oh, animate first, animate 0 to 100, and then take value on each update and then apply it to the set translation X, which is not, as I said, a good way to do it. Better way to do it is object animator. So object animator will work. So you will say apply it on the text view. You will say on which value, which property. The thing is, you have to have set translation X method in your class, because if you want to, what this will do, it will use reflection to get this method, and then to actually animate the view. The problem with this is, well, it uses reflection, so it's kind of slower, and it's not what you really want to do. Then we have Animator Set. As you might already know, this is how it looks. It's pretty, I don't know, it's not really that convenient to use, especially if you have more and more things and you want to do some complex things, you want to have some delays between animations. The more things you want to do, the harder it gets to control it. So we're going to get around that with our reactive implementation. The final class is this View Property Animator. As you already probably know, if you ever did animations on Android, this is kind of a go-to class for animating views. So what it does, it provides a great API to kind of schedule the animations you want to run. So we initialize it by calling textView.animate. And then you can do, it's basically using a builder pattern, so you can use, you can just set the properties you want to animate on it and in what fashion you want to animate it. So for example, in this case, we're just going to say animate X property to 50, Y property to 100. You can set a translation, you can do whatever. Then you can declare duration of the animation, the interpolator you're going to use. Interpolator defines like in what way the animation is going to run. Is it going to run linearly? Is it going to like go faster in the beginning, slower in the end, things like that. And we can declare some start delay for the animation. Also, you get the listener. So with this listener, you can listen to specific events happening during the animation runtime. So you get this on animation start, animation end, cancel, and repeat. Now, what most people will just use is what we will usually just care about the end action. So we will just say, so they in API 16 they decided to introduce this with end action. So you can just say, with end action you define runnable, and something will run when this animation is finished. Now there's a view compat with the compatibility library. You can turn this into view compat.animate, so you can basically wrap the text view. It provides the compatibility for the API prior to 16, and you don't get view property animator, you get view property animator compat. So you can use this with end action on API, any API basically. Okay, a few remarks about this whole animation process. As soon as you call animate, the animation is scheduled to run. So once we say view compat.animate, it's already scheduled. I mean, you will define the other parameters of your animation, but as soon as the main thread is free to run the animation, it will run. So it's scheduled, and they have also this start method, which is optional. I'm not sure was it necessary before, but right now you don't need it. So as soon as you define the view property animator, you're gonna get the animation is gonna get scheduled. Okay, the other thing, only one animator can animate a specified view at a particular time, which means just if you're animating a view, one animator can perform on it. So if you want to do multiple animations, like I want to move something but also want to expand it, you have to define it in one animator. You can't just define two of them and then apply it at the same time, because just one is affecting one view. So you need to keep that in mind as well. Okay, now why RxJava? Well, first of all, what is RxJava? In some short sentence, is a library for composing asynchronous event-based programs by using observable sequences. Those of you who worked with it already know that. For those of you who don't, let me just keep it. For those of you who don't, we basically are going to convert objects into streams, so we can stream data and then perform some actions on it, as you'll see. So we can use RxJava chaining system to improve our animation logic and give more power to our animations. That's what I said right now. Yeah. Okay, so we can wrap animators inside RxJava objects. Why Kotlin? Well, basically, it's cool, right? Right now to do everything in Kotlin. But it provides some nice things like lambdas, extension methods. Syntactically, it's more pleasing. It's easier to put it on the presentation. And everything I do with in Kotlin here, we can do the same in Java. But also, the previous examples were in Java to make it look more ugly. Okay, we're just going to quickly go to some base reactive types in RxJava2. We have observable, we have flowable. In short terms, like for those people who didn't work with it, it's not that important now for me to explain the difference. What it does, it receives values as they come in the onNext method, and once the stream is finished, it will receive the onCompleted method. Now we have RxJava2 has also this single base type, which will just receive one value and finish with it. So it will either finish it on success and give us that value, or it will throw an error. So the first two, the first and the last one, I faded them out because they're not really that important right now when determining the difference between these types. The last one, and that we're going to use the most, is the completable. So completable will execute an action and it will finish. So it doesn't care about the return value. It will either complete or throw an error. So which is basically what you want to do with animations, because you usually want to animate something and get the callback that the action is done. There's nothing really to return there. So this is what we're going to focus around. Okay, let's start with some simple example. I hope you see the code. It's a little bit small because there's going to be a bit more of it. Okay, so let's just create, for example, a fade-in method that will take a view and take some duration and it will animate it, and it will actually return a completable that once we subscribe to, it will start the animation, and once the animation is done, we get the onComplete event. So we have this static creator, completable from action, and then we can define the same thing we use. ViewCompat.animate, we say we want to apply the animation on the view that we pass to the method. We want to set the duration we pass to the method. And since this is a fade-in method, we want to animate alpha to 1F, which means 100% transparency. Now if we just use this, let me go back. So why is this not going to work? This is not going to work because completable from action will execute this given action once someone subscribes to it. But once you subscribe to it, it will execute this ViewCompat.animate, which means it will schedule the animation, and it will end up right away. So you won't wait for the animation to actually finish. It will end up right away. It will start the animation, but it's not going to wait till the end. So what we need to do, we're going to introduce here. This is some like naive approach that we're going to use here. If you do the real implementation, you're going to have to take care about some more things. So we're going to create a completable subject, which is the subjects are objects which can call methods like onComplete, which we're going to use here to actually listen for the animation's ending, and then use this subject to send the onComplete event. So people also observers can subscribe to the subject because subject is a completable. So we're going to create this one called animation subject. So we're going to say the same thing, animate with duration alpha, and then we're going to say with end action. So once it ends, we're going to call animation subject.onComplete. And of course, we need to return it. So once someone subscribes to it, it will start the animation, it will schedule the animation, and once it completes, it will call the terminating event. Now the thing here is this also. So once you call this method, it will also start the animation right away. So we still didn't like figure out the problem of starting the animation. Okay, we have the end. Once it ends, it will call onComplete, but it will start immediately. So what we're going to do is we're going to say annotation subject do onSubscribe. So once someone subscribes, we're going to schedule this animation, and once this animation is finished, we're going to listen to the end. We're going to call onComplete. Also, this do onSubscribe returns the new instance of animation subject, so we can just return that. Okay, let's go on. Okay, let's create a simple animation using what we currently wrote. So we have let's say we have 4 buttons, and what we want to do is animate them, fade them in, with duration being 1,000 milliseconds, 1 second. So what we get is this nice syntax, because we're using RxJava operators. For example, we have this and-then operator, which operates on completables. So you can say run completable and then run another and then run another. And what's it going to do? Once we subscribe to it, it's going to send subscribe event to the first one, which is going to execute. And once it's done, it's going to send subscribe to a second one, and so on, and they will push down the chain. So if one of them throws on error, the whole chain throws on error. So once you subscribe, the actual animation will start. So also we need to define alpha 0 because we want to start from buttons being invisible. Okay, now this is how it's going to look. So you have really like a simple syntax, executes nice animation, and if you would do it the regular way, it will be a bit harder. Not on this example, but as we go forward, it's getting harder. Okay, what we can do here is, as you see, we're in Kotlin, so we can make this also extension method. So that will extension methods are methods that you define for a certain class, and then you can apply those methods on objects of that class, even though you don't have access to that class. So you can say, as you see, we apply fade-in on the view, so we can make it extension of view class. By defining this, we say view.fade-in, and then we just need duration. So, and we say ViewCompat animate this because the object we're going to performing method on is now referred to as this. We can get it from this. So now this becomes even simpler. So this is what Kotlin can do. In RxJava, you would have to use the first option. So you have now pretty nice syntax. You can basically read what it's going to do. Fade in button 1, and then fade in button 2, and fade in button 3, and so on. Okay. Also duration. As you see here, we specify duration each time we want to execute, and every time it was 1,000. So we can set some default value. So these are like default parameter values in Kotlin as well. So we can say the default execution time for animation is 1 second. And now we can basically remove this duration, and each of these animations will execute in 1 second. If we would like to have, let's say, button 2 execute in 2 seconds, we can specify specifically for that button. And the other ones will have 1 second passed in. Also, okay, let me just, so this is sequential execution. We have this and then, which will execute animations one by one. For example, we want to execute them all together. We have, in RxJava, there's also operator merge with, which will merge completables as they're passed. So they will all be run at the same time. And the last one that calls onComplete, then the whole thing will call onComplete. So it runs all of them, and it finishes once the last one finishes. So if we change it to merge with, we can basically get the animation where all of the buttons are fading in at the same time, with the second button fading a little bit longer, as you can see. Okay. I made this one. This is actually button 1 now fading, but you get what I mean. Okay. Now we can even group the animations. We can do some more advanced stuff. For example, you want to fade in first 2 buttons together, then you want to fade in third and fourth button. So you can say fade in first, merge with fade in second, and then fade in third button and merge that with fade in then fade in fourth button. We can even make this. Okay, I should have not analyzed it. Now we can put it in a separate method, and we can also create a convenience method where we're going to say we're going to create a method that's going to be called fade in together, which will take 2 views and fade them in together. So we're basically going to do the same thing we did up there, just for generic view. And then the up there, we can use even nicer syntax. So we can say fade in together buttons 1 and 2, and then fade in buttons 3 and 4. And the animation we get is this one. Okay. Okay, now I'm going to do a little bit more advanced example. Let's say we want to do the animation in some time intervals. So we can define this time observable, which will emit a number each 100 milliseconds. So each 100 milliseconds, it will say, it will go 1, 2, 3, 4. Then we define another observable, which will emit our buttons. So we have 4 buttons in this case. It will emit those 4 buttons. This observable will basically emit them immediately, since we have all 4 objects, and we call just, so it means just emit all of them. And what we're going to use is operator called zip. How zip works? Okay, so the stream that we have up here is the first one, the time observable. So it will emit numbers in certain time frames. So let's imagine this is 100 milliseconds. And our second observable, button observable, will emit our views. And as I said, it's going to emit them right away together. So what zip does, zip waits for one object to come from the first stream and takes one object from the second stream and then merges them together. So even though all these 4 will be available right away, it will wait for the first stream to send their object. So you will merge first object from this one with our first view, and then 100 milliseconds later, when the second comes in, it will merge with the second. So you basically get our views coming in certain time intervals. Okay. And now we defined what's called the by function is in RxJava, which takes 2 objects, returns a third one. So we want to take time, and we want to take view. And what we're going to do with it is we're going to say view, fade in the view, and then subscribe to it. Now, the interesting thing here is we don't need time, so we can also remove the time. And this is the final creation. You can even make it, if you make helper methods as I did before, you can make this even more pleasing. So you can say execute with some delay or things like that, and then you can make it syntactically more pleasing. So how it's going to look is just going to fade in all buttons with 100 milliseconds delay. So it's like you get a lot of power in composing animations with just a few changes. Okay, now this is one project I started for this conference. I kind of wanted to make the whole thing more generic. So instead of having to define the whole thing every time we want to make some animation, like want to fade in and then fade out completely like new structure, instead of having that, it's easier to have like some kind of a generic structure. So I started this project. I advise you, if you're interested in this and in using it in your own application, that you look into it. It's still not, I plan to release this library in maybe a week or two, but the initial code is there, and you can see how you can use it for your own animations. So what it does, it provides wrappers for animations, the same thing we talked about here. It also contains some common pre-made animations, which you can basically do. So you get this generic animator builder, and then from this you create your own animation. So whether you want a pop animation, you want to rotate, you want to spin, whatever you want, you can basically define it for yourself. It gives you more powerful reactive constructs, and I said if you look into it, feel free to make pull request issues, whatever. Okay, so we're going to see how it works, but more importantly, we're going to see what is possible and what you can do for yourself. So let's say we're going to create this fade in, and it's not going to return completable, but it's going to return animation completable. I made this animation completable, so I extended the completable object, so we have more options. One important thing is, in our previous implementation, we couldn't cancel the animations. So they would run, they would give a feedback, but there's no way to cancel it. Now you can create animation completable, you can check the source code, that will actually stop the animation once you unsubscribe from it. Other thing, if you noticed, in this fade-in method, we didn't have ways to react on animation start and all these listeners we had in Vue Compat library. So this is an example how you can just build, for example, fade-in animations. You would just say animation builder, which is also a class there you can check. And then for Vue, basically it imitates the Vue, how Android does it, but it just gives you a reactive, it gives you the output in reactive manner. So you can say, for some Vue, put alpha to 1f, duration to 2 seconds, and then build. Now, once you call build, we're going to get the animation. Animation, I define it as immutable object, so it holds parameters for the animation. It's not going to start anything, so it's just going to define how the animation is going to look. And you can define more of them for one view because it doesn't execute anything. And now we can say to completable. It's also convenience method. It just will create animation completable. So it will take this animation, wrap it in a kind of reactive way, and once you call subscribe, it will execute the animation. If you dispose it before it's finished, it will stop the animation. Also, there's convenience method just called build completable. Okay, so what also it provides for you is a builder on the animation completable. So this here is already, we have animation completable object, but you can now add some callbacks to it. So you can say, do an animation ready, do an animation start, do an animation end, things like that. So you can also, it gives you that power. So it's really nice. You can pass lambda methods in it. So you can say, for example, once the animation is ready, we want to set it to alpha to 0. So we want to actually show the fade in. We don't have to do it before the animation. We can do it right in. Once the animation, this is not some like, once it starts, we want to set some other text view and show start. Once it ends, we want to say ended. Also, we can remove view here. We can use just it's at alpha, and since we don't need these two, we can just call text view. We can just set the text on the text view. Okay, and this is also what you do, how it looks. So we can say fade in some view and then fade in some other view. Subscribe to it. Also, you can create for yourself, or you can use these. You can use methods to kind of schedule these animations as you want. So you can define sequentially, and then just put the animations fade in some view, fade in some other view. So instead of calling and then, you can just create your own methods. RxJava has operators for it, same as together. So I think it's called merge concat and merge. I'm not sure. I can check it for you later. Okay, so when I said you can define out-of-the-box animations, which means you can define things like, things like this. So you can have some predefined, for example, durations. So you can say fade in quick, fade in slow. You can play with it any way you feel it's optimal for your application, the way you need it. So you can have this sequentially fade in quick and fade in slow views, or together, or in whichever way you want. So here, for example, we define interpolators. Down there we define duration, but we cannot define it at all. All of that. So you can just like make methods that you're gonna use and that you need. Okay, now here's like a couple examples. We're gonna use kind of the same animation, but we're just gonna make our chain a little bit different and see how like easily we can change the animation with just a couple of lines. So for example, here we're gonna show a floating action bar. We're gonna scale it up, so it's scaled to 0. We're gonna scale it up. And then we're gonna fade in 2 text views together. And finally, we're gonna fade in the progress bar. So once we subscribe to it, we get something like this. So it's pretty simple, and you get really nice animation. Now, if you wanna, you can even play with this chain. You can change it. So you can say scale up floating action bar, then do these together. So and then do together spin. Let's say we want to spin for 360 this floating action bar, and at the same time show the text views, and then fade in the progress bar. If we run this animation, it will look something like this. And the final one, for example, we can do all of this together. We can scale up the floating action bar, fade in the first text view in some shorter time, and then let's say fade in the second one in some longer time, and we want to expand the progress bar. I define expand here as being, say, having a scale x set to 0 and then going to 1, so it will look like the progress bar is actually expanding. Once we subscribe to it, we get this kind of animation. Okay, so I have a bit more time left, and that's pretty much it. I didn't want to go too much into details. I just wanted to show you what's possible. And you definitely, if you want to use it in your own applications, I think you should go and play with it, see how it works, and definitely make your own methods. So yeah, we have time for questions then. Thank you.
Так, ну и теперь время вопросов.
So now it's question time.
Hi, my name is Sam. Thank you. As I see, you love Kotlin for the opportunity of getting rid of different structures and many boilerplate code. My question is about the last example where you have used, as I could see, you've used extension properties for Kotlin actions. I find it kind of unnatural to use the properties to call actions, and why not extension methods?
Oh, you mean that I didn't use extension methods in the last example?
Yeah.
That's just like I wanted to show the syntax. I missed that. Yeah, it should be there. I didn't like.
Oh, that's a mistype.
Yeah, because in the project I created, I didn't create. It's in Java, so it didn't have extension methods. It will need to have a separate module, which I will make like Van Gogh. Kotlin, so then you will be able to use extension methods with Kotlin. I just used what I had right now in the library. Okay, so it will be a separate thing because it's written in Java. So you will have to define it for your Kotlin part outside of it. Do we have one there?
Hello, my name is Maxim, and my question is it possible to apply 2 different animations to the same view at the same time? For example, I'd like to fade something in and make it larger.
Not. Yeah, I get it. It's not possible because that's a limitation of Android system. So it gives you view component API, And then you can define, if you would have to create your own method. So if you want to, I don't know, expand it and rotate it at the same time, you will need to create a method called expand and rotate. Okay, you can call expand merge with rotate. So you need to have one method that does all of that. So you will have viewCompa.animate, and then you will have rotate and then scale up all in the same like in the viewCompa animator. So you basically you're limited to that. If you want to do things like that, you have to write your own custom method.
Okay, thank you.
Okay.
Hello. My question is there any way to add some actions to the view after it completes its animation?
Yeah, as I said, you have, for example, in this last one, we have do on animation start. You have ready, cancel, repeat, so you can do animations on each of the steps, if that's what you mean.
Well, I thought you can, I don't know, make a fade out animation and then call view set visibility gun to it.
Yeah, you
after
can do
it's
that.
complete.
Yeah, because once you call do on animation end, it will give you the view in the stream. So you can just say that view, you can apply set visibility to invisible on that view or gun.
Okay, thanks.
Thanks for an interesting team. Does I right understand what the animation schedule is in main thread and FPS schedule? Yes.
It really doesn't matter here on which thread you do the whole thing because because it uses viewCompa animator below the hood, right? So as soon as you create your animation using that animator, using that API provided by Android framework, it will schedule it on a main thread. So it will be scheduled, but it will be scheduled on some other thread, but it will run on the main thread.
And the second one question.
Yeah.
In your project, when you close activity and open up again, does the animation pause and or does animation
No.
complete fully?
It doesn't because once you run a completable, it acts on the view. It holds a weak reference to the view. So we hold a weak reference. Once the activity is destroyed, the view gets destroyed. There's no reference. It automatically disposes, and it doesn't run. So once you retain the state, you would have to run it again. So if you want to do things like saving state, you're animating something and it's in the midway, and then you want to, once you rotate, want to continue from that point, you would have to handle it yourself because it's.
I may use my own schedule for that. Yes.
I'm sorry.
I can write my own schedule.
Yeah. It's basically acting as a completable. Animation completable is just extension of completable. So everything you can do in RxJava with completables, you can do here. So if you're running if you're like restoring completable in your app, you can restore this one as well the same way.
And in your project, when for example, animation is 10 seconds,
Okay.
And when you close activity, 20 seconds left and open up again, does the animation complete it? Or?
No. It resets and everything is.
Oh,
you
it's
basically
cool.
run the whole life cycle once again.
Mm-hmm.
Right.
And when I use my own schedule, I can put logic, then the animation fully completed.
Yeah, if you want to, I didn't go with it because Android does it, if I'm not mistaken, by default. So if you initiate, for example, you initiate activity, you set visibility to 0, and then you rotate, and you don't handle anything, it's going to be, if you set to 0 at some point, and then you rotate, it's not going to remember the state. So once you reinitiate the activity, it's just going to be in the default state that you started with. Android doesn't save states of the views by default, if I'm not mistaken. So I just went with that, do it the same way as Android framework does it.
Thanks.
Okay.
Hello, my name is Dima. So your code looks very pretty, but we built our code on RxJava on Completable, but can we change word subscribe on some explicitly?
I'm sorry, instead of using subscribe, to use some other
Yes.
word. Yeah, I think you can do it. You can just define a method that you will pass, but I wouldn't do it. I mean, you would have to. Subscribe has many parameters, so it's not just subscribe. You have, when you actually subscribe, you can listen to events. So you can have a bunch of actions that you can subscribe to Observer. So you will have to, if you want to call it somewhere else, something else like animate, then you would have to define animate for every of those subscribe methods. You can you look at RxJava documentation, and then they have like, I don't know, 10 subscribe methods with different parameters. So if you would want to do the same thing and then call it animate, you would have to actually like do it for each of those subscribe methods. But you can do it. I mean, if you don't like the subscribe word, you can do it with animate or something.
Thank you. I have a question. I'm from the right side. I'm here.
Okay.
First of all, thank you for your talk. And my question is, are there any pitfalls when you use animations and RxJava? Because like kind of leaking context or whatever it may be, are there anything special we need to care about?
Yeah, you definitely need to care about that. You need to, about leaking context, which means not holding strong references to the views. So if they get destroyed and you call .animate on them, they're gonna not gonna be there, and it's probably gonna crash. So that's one thing. The second thing is actually when you're disposing the completables, you want to stop the animation if that's what you want. So things like that, you need to think about it. Also, what was already previously asked, you can't execute two animations on one view. They're different. You have to define them in one animator. So I would say that's one, but that's not the pitfall of RxJava. That's the pitfall of Android system. Yeah.
Okay, thank you.
Thank you.
On the title, there is RxJava2. So, is there any particular reason why you use RxJava2? And because we, for example, in our project, we use RxJava, and I'm not so familiar with RxJava2 and the benefits which it brings. But yeah,
it won't bring you much benefits to the animations. I mean, if you go, I think that you have one library. I'm not sure how it's called. Maybe Rx animation, something like that. That actually uses RxJava1. And you actually can perform animations. The difference is, there are a lot of differences. RxJava2 uses kind of better, it's called degree of reactive streams, so it's a lot better in a way. And I mean, if you're using RxJava1, you should really start to look into deprecating it, because the RxJava2 was built from scratch to handle back pressure, and you know, in RxJava1, observable handles even if there's a back pressure, it should be handled or not. In RxJava2, you have observable and flowable. So you use observable when you don't get that much objects coming in. And if you have a bunch of objects coming in and you need to handle back pressure, then you would use flowable. So they make clear distinction. It's more optimized. I suggest, I mean, we ditched it completely, RxJava1, and I really suggest that everyone who still uses RxJava1 does it and use RxJava2.
Thank you.